MOSFETs stands for metal oxide semiconductor field effect transistor. Very similar to an NPN transistor in that it only switches on once you reach a certain voltage. Thinking back to NPN transistors, it's just two N-type materials sandwiched with a P-type material in between. If you get a voltage above 0.7, you'll switch it on. The MOSFET works in a very similar way, except its switching voltage is slightly different. The circuit symbol is different as well. Instead of having a basic collector and emitter, you've got a gate, a drain and a source. Switching voltage is usually about 1.8 to 2.2 volts. If you get required voltage across this gate here, you'll allow current to flow from the source through to the drain. So the gate has to be open to allow electricity to flow through it. The source is the source of the electricity, and the drain is where the electricity comes out. If we look at a symbol for the internal structure of the MOSFET, we've basically got a P-type substrate here with lots of holes in it, but there are still some electrons there, so when you apply a voltage across this gate, it pulls those electrons up to the top and it creates a layer of electrons here. Just them sitting there on their own doesn't do any good. You need to have a voltage between the source and the drain to cause these electrons to be pulled from one N-type material through to the other. You do that by applying a voltage between the drain and the source. Flows from positive to negative or negative through to positive. So that's essentially how the MOSFET works. You need to have a voltage across the gate as well as a small voltage across the source and the drain. So the voltage across the gate creates a field which pulls the electrons up, and then the voltage between the drain and the source pushes those electrons between the N-type material, and that's how it conducts.